Hello everyone, this is Alice Gao. In the previous few videos, I've introduced the elements of the variable elimination algorithm. I talked about what is a factor, then I talked about the different operations we can perform on a factor. Restrict, sum out, multiply, and normalize. In this video, I'm going to put them together to describe to you the entire variable elimination algorithm. The algorithm can be summarized on this slide right here. Suppose we want to calculate the conditional probability. So we have one query variable xq, and then we observe a bunch of values for a bunch of evidence variables. So these evidence variables are x01 up to xoj, and each one has an observed value. We may also have some hidden variables. So hidden variables are all the variables that do not appear in this query. Now, what do we do for the variable elimination algorithm? First of all, we are given a Bayesian network, and each node in the Bayesian network has a conditional probability distribution attached to it. So for each conditional probability distribution, we will construct a factor. Basically, we will take the distribution and put it in this abstract table form where we don't know what the numbers mean, but it still looks like the same table that we put the conditional probability in. Next, we'll deal with the evidence. So we observe some evidence, and this is highlighted in blue here. So for every value that we observe, we're going to take the corresponding variable and restrict it to that particular value. So we're going to use the restrict operation here. Next, we are going to deal with the hidden variables. The hidden variables should not appear in the query, so we need to get rid of them. How do we get rid of them? There could be multiple hidden variables. So first of all, we have to pick an order in which we're going to go through them and then get rid of each hidden variable. Now for each variable in the order, what do we do? Well, we're going to look at the list of all of the factors and find those factors that have these variables in them. And we'll multiply all of such factors together. Okay, after doing the multiplication, we have one factor which contains the hidden variable that we're trying to eliminate. And all other factors do not have this hidden variable. So all we need to do is sum out the hidden variable from the single factor. Okay, so the steps I'm describing here actually correspond to the derivation we did before when we have a summation over a particular variable. So we want to sum out the variable, right? And what we did was we took the summation and move it to the right. And we move it to the right as much as possible so that the summation is only over terms that involve the variable we're trying to sum out. Now, we may have to do this step multiple times because we may have multiple hidden variables that we need to get rid of. So after we get rid of all of the hidden variables, what do we have left? Well, we have the query variable, and then the evidence variables are also gone because we've restricted them. So all we have left should be the query variable. Well, even at this case, we may still have multiple factors left, right? We could have multiple factors. Each factor only contains that query variable that we're interested in. So now we need to, if we have multiple factors left, we need to multiply them together. And finally, we are looking for a conditional probability, so it's part of a distribution. The last step is that we will take the single factor that we got and normalize it so that it represents a valid probability distribution. These are all the steps for the variable elimination algorithm. It is pretty abstract because this algorithm is supposed to be a general algorithm that works for any kind of Bayesian network, and it does. I will stop this video here. In the next video, I will trace through the entire Holmes example to show you how the variable elimination algorithm works exactly. Thank you very much for watching. I will see you in the next video. Bye for now.